In this lesson, we will evaluate and rewrite expressions involving rational exponents. So that means your powers are going to have fractional powers. And we're going to solve equations involving expressions with rational exponents. So your equations are going to look something like this. You're going to have a to a fraction, m over n. The m is going to be the power of a, or it's going to be the power of whatever base this is. The top number is always the power. The bottom number is going to be the root. So if this were a to the power of half, it would be a to the 1 inside the square root of a. Okay, let me write that down so that makes sense. If this were a to the 1/2, it's going to be the top number would be the power inside the root. So that would be a to the 1. The bottom number is the root, so this would be the square root of a. A to the 1/2 is the square root of a. The top number, remember, is always the power, and the bottom number is always the root. Now, when I say the power, I mean the power when it's inside the radical, okay? So let's start here. This is b to the 1/2 to the half, or to the squared, b to the 1/2 squared. So some of you already know that that's the square root of b, because a to the 1/2 was the square root of a, right? So if I take the square root of b to the power of 2, that's just going to be b. Now let's use our properties from yesterday to help us with this. This is going to be multiplication, because I'm doing a power of a power, and what's half of 2? Half times 2 is 1. So this is just b to the power of 1. 16 to the power of half. The 1 is going to be what 16 is the power of, so that's going to be just 16, because it's 16 to the power of 1. The bottom number tells me the root, so this is just the square root of 16. So 16 to the power of half is 4. And you can type that into your calculator and see if your calculator will work it out as well. 38 to the 1/2 is just going to be radical 38, because I cannot simplify. 38 is not a perfect square. I cannot simplify this down. This 2 means it's a square root. The 1 means it's 38 to the power of 1. So perfect squares you can work out, but if it's not a perfect square, you're going to have to leave it in radical form for this lesson, okay? So here we go. 25 to the power of half. That would be radical 25, because it's 25 to the 1, and it's a square root, and that would be simplified to 5. How would I write radical 18 in a power form? Well, 18 is the number in the radical, so that's going to be my base. Here it's to the power of 1, and this is the square root. So we'll already write that as 18 to the 1/2. Moving on. 5x to the 1/2. The 5 has a power of 1 next to it, so the 5 just stays 5. The x is what has the power of half next to it, so it becomes radical x. So this is 5 radical x. I cannot simplify this, so I leave it in radical form. It's x to the power of 1, so it's just x, and it's the square root of it. This is radical 8p. In this case, all of this is underneath the radical, all of this. So you are going to take 8p, this entire term, to the power of 1/2, because it's just the square root. So this is 1p radical of 1/8 radical of. So try the example in your notes. I'll give you a couple examples to work of going to radical form and working back. Now what about a cubed root? If a is cubed, then a is the cubed root of b, and a cubed root looks like this. So if a to the power of n, for any positive integer n, it is going to be the nth root of b, if we're using this rational form. So in this case, this is the cubed root of 27. So remember, inside, this is going to be 27 to the power of 1. So we're going to take 27 and we're going to write to the power of 1. Now my denominator represents what the root is, and in this case it's a cubed root, so that's a denominator of 3. So this would be another way to write the cubed root of 27, 27 to the 1/3. Now, could you simplify this out. Absolutely. I believe the cubed root of 27 is 3. You could simplify that out. Fifth root of 32, could you simplify that? Absolutely. I believe you would get 2. Another way to write this, though, is what we want to practice. So this would be 32, because it's a 32 to the power of 1. And then the bottom number tells me my root, which is 5. So go ahead and check. You can type it in either way, but you can check those on the calculator. Real quick here, if you want to do a root that's other than a square root, you're going to use a second power key, which looks like this. And you have to put the 3 in, then hit second power key, and that will be the cubed root. If you put the 5 in first and then second power key, that would be the 5th root. So just a quick review of your calculator keys there. So try the examples in your notes of how to do roots that are other than 2. Now, in this case, we have a base of b that we have to a fractional power to another power. We're going to use our simplifying by multiplication. So this is 1 over n times n. 1 over n times n, if we just do a little bit of math right there, is just going to be b to the power of 1. So this is just b. 8 to the 1/3 would be the cubed root of 8 to the 1, which we can simplify and get 2. And you could try that on your calculator if you like as well. So how about 125 to the 1/3? That would be the cubed root of 125. Try that on your calculator and see what you get. I believe you get 25. No, it's 5, sorry. Type that into my calculator here. And then 1,296 to the 1/4. What you're going to do is the 4th root of 1,296. If you type that into your calculator, I believe you get 6. So try that and see what you get. Go ahead and try the examples that I give you in the notes. Make sure you have your calculator handy. Now, if I have b to the power of mn, remember my first, this is going to be the nth root of b to the m, because my numerator tells me what the power of the base is in the radical, and the denominator tells me what the root is outside. So this would be another way to write it. In this case, 8 to the 2/3, this would be the cubed root of 8 squared, which could also be written as the cubed root of 64, which could also be written as 4. And if you just type this into your calculator, it would tell you 4. In this case, I have 64 to the 2/3, so that's going to be the cubed root of 64 squared. So if you do a little bit of work here, 64, that's going to be 16 when you type that in. 36 to the 3/2 is going to be the square root, because this denominator is a 2, of 36 cubed. And you can do your calculation of that, and you should get 216. When you are writing, I'm going to show you on your notes how I want you to write all your answers, but when you're writing, you're going to have to write this form, the radical form, as well as the solution. Because I don't want you just typing things in your calculator and not knowing how you're supposed to write them. An exponential equation is an equation in which the variables occur as exponents. So in this case, we have 6 to the power of x equals 216. So I need to figure out what that power is. 6 to the power of what would equal 216? So you can use some guess and check if you'd like, or you can try to rewrite this as a 6 to what power? So you type some things in, you know, 6 squared is 36, and as you work it out, you see, hey, 6 cubed is 216. So if I rewrite this as 6 cubed, look how I have the same base. So x is equal to 3 then. And you can see how, because this x has to be 3 to get 216. In this case, I have 25 to the x minus 1. So I'm going to try to figure out here how I can write this 5 to get 25. So I'll show you how that looks here. This 25 is the same as 5 squared. So I just changed this 5 to a 5 squared because I wanted the two sides to match. And it was actually easier to change this 25 than it would be to change this over here. If you would look at this, this is now 2 times x minus 1, so we can go ahead and distribute that. So we get 2x minus 2. And I'm going to go ahead and just put what that is equal to. So if we wanted to solve for x, we would just take these powers. So I would just take 2x minus 2 equals 1, and let's just solve this for x. So we're going to add 2. So I get 2x is equal to 3, divide by 2, and we get x is equal to 3 halves. There are a couple examples that I'd like you to try in your notes. We'll have one where you just have to match the bases, and then we'll have another one where you have to do a little bit of algebra. So try the examples in your notes. All right, we want to find the SPF that absorbs 100% of UVB rays, and this is the equation that we're going to use. And the P is going to be for percent, so we're going to just change that P to 100. The 50 we're going to leave as 50. The F is what we're trying to find. The SPF is F, and it's to the power of 0.2. So to simplify this down here, we really want to get rid of this 50. So if we divide this side by 50, we also have to divide this side by 50 because that's a multiplication relationship. That's why we divide. So 100 divided by 50 is 2. And we have 2 equal to F to the power of 0.2. Now, what we could do here is we can try to figure out what this would be as a fraction. So 2 is equal to F to the 0.2 is the same as 1/5, right? And what we know about 1/5 is it's going to be the 5th root of whatever that value is. So we want to make this match, this power match over here, because right now we have a 1, a to the power of 1, and that doesn't match. So what we could do is we could make this a 1 by taking 2 to the 5th to the 1/5. Because 5 times 1/5 is 1, and we wanted 2 to the 1. And now we have a 1/5 power that matches as well. So 2 to the 5th is what would make this power get to 1. And so that is what F has to be, is 2 to the power of 5, which in this case is 32. We'll do another example of that to help you grasp that concept of trying to make 1 over here as well. So try the example in your notes.